Okay, you can check how you did. If you had trouble with completing the square, remember that in changing it to standard form, so one of the things that can help you thinking about this is looking at your formula sheet or writing this down from memory. This is what standard form looks like. The A value is factored out. So the first thing I'm going to do is I'm going to take that 2 out, but my number by itself is at the end, so I left the -7 at the end. Now, we need to change this into something squared with an x here. This 1 tells me that this has to be a half. And if that's a half, and I multiply it out, I would add a quarter. Adding a quarter actually means I've added a half, so I would have to subtract a half, making -7.5, or if you had that as a fraction, -15/2. So what we're going to do in this unit, not yesterday, but I guess last week, we were graphing lines and shading above and below, and sometimes we graphed the line with a dotted line, and sometimes we graphed it with a solid line, whether it was greater than or greater than and equal. We're going to do the same thing with parabolas. We're going to be given a parabola, like y equals x squared plus 4x plus 1, but instead of an equal sign, we're going to get an inequality like this. Well, what does that mean? We're going to take that same inequality, and in order to graph it, we're going to think about completing the square or changing to standard form, just like we did before. Well, if I have that plus 4x, the only way I could get a plus 4x is if I had a plus 2. And if I had a plus 2, this would need to be plus 4. So to compensate and do the opposite, I would have to subtract 4. So we get the parabola with a vertex. Maybe move this line over a bit. At -2 and -3. And my A value is 1, so normally I would go over 1, up 1. Here, I'll graph it in blue. Over 1, up 1. Over 1, up 3. Over 1, up 5. There I have a bunch of points. But this time, instead of graphing just a parabola with an equal sign, we're graphing an inequality. Y needs to be less than. And since there's no equal sign here, we'll draw this parabola with a dotted line. Now the question says, can you use a test point to see if it's true? Okay. My favorite test point is this one right here, 0, 0. Why that's my favorite test point? Because it makes the mental math really easy. If I plug in 0 and 0, whether I plug it into the original here or here in my completed the square, in my standard form, is 0 less than 1? True or false? True. That tells us, as far as shading goes, we should shade this section that includes 0. Okay? Does it also make sense for you from before that if we had the less than sign, a shortcut for shading is if the y has to be less than something, it would be below? We did the same thing with lines. Sometimes we shaded above, sometimes we shaded below. So we could use that as another reason to say we should shade below. Couple of reasons why I might not want to use 0, 0 for my test point. 0, 0 is really close to my graph. What happens if I had sketched my graph just a little bit bad and I happened to think 0, 0 was in the wrong section? Not because it actually was, but just because my graph was bad. That could happen. So sometimes we like to choose a test point that, like, for sure is in a section. Or, you know what's a really nice test point to do on a parabola? Is choose something, say I choose this point right here. -2, comma, 3. What if I chose that as my test point? And why would I maybe like to choose that point? Well, y would be 3. And if I choose -2, what happens to this whole thing that's squared? It's 0. Is 3 less than -3? No. That is false. So this section here is not true. And that's why this section's not shaded. And then I would also know to shade underneath this parabola. Okay? Again, for the shortcut, we are going to talk about above the graph and below the graph. We will never talk about inside or outside of the parabola, because it doesn't actually work. Sometimes a less than 1 might be inside, and sometimes a less than 1 is outside, depending on how the parabola flips. So to be careful with that. So again, we're going to talk about shading above and below, and this lesson is basically combining your skills of graphing parabolas from chapter 4 and using what we learned with lines with the dotted line and shading above and below. So, here's on the next page, just looking at some graphs. Does this graph make sense that with the greater than sign, it's a dotted line? We draw a dotted line when it's greater than or less than with no equal sign. Second, why is this part shaded? Because if you take any point, greater than is shading above. If the y has to be greater than the graph, then it has to be above. So it makes sense that this graph is shaded above. If you have a less than or equal, that equal sign, now we draw it as a solid line. And the less than, take any point and go below, that's why it's shaded below. So these are quadratic inequalities, where you graph and shade either above or below. All right, let's look at our first example. Graph the inequality. First of all, in order to graph a parabola, here, I will write off to the side. Remember all the strategies for graphing? This is probably the most common strategy. If you have the vertex form, you know the vertex, and you can draw the graph. First thing we have to look at, is this in vertex form? And if it is, what is the vertex? If it isn't, then we're going to need to change it to standard form.
It's technically not in standard form, but it's just because the A isn't outside the bracket.
So, but the question is, do we need brackets? Like, are you saying, would it be if I wrote it like this? Would this be considered? Or do I need to write the brackets? Do I have to have it like this? Plus, minus 4. Are those basically the same thing? Okay. I mean, when I write it like that, it's really easy to see, right? The vertex is 0, -4. which is, it's good to see that sometimes, because this is like a hidden standard form. It is in standard form, but sort of hidden, because you're missing the P. Well, you're missing the P because it's a 0. You don't have to write zeros if you don't need it, right? Right, wouldn't it be annoying if I asked you, what's 2 plus 2? Write your answer correct to 25 decimal places. And then you have to write 4.0000000 25 times. That would be really annoying. Sometimes we don't write the zeros because they're not necessary. So we do have our vertex. We could draw this. We could draw 1, 2, 3, 4, 0, -4. Does this graph go up or down? This parabola? Up because of the +3. And that +3, as far as the shortcut, you could go over 1, up 3. So it'd have 1, -1, and -1. Then over 1, up how many? If you went over 1, up 3 the first time, the next time you're going to have to go over 1, up
5, 6.
4. Because normally it went like this, right? Over 1, up 1, over 1, up 3, over 1, up 5. So now it went over 1, up 3. Next one is going to go over 1, up 9. So we would have the point 2, 8. That's using that shortcut of the 1, 3, 5 and multiplying it by 3. If you want to find points, you can always just plug them in. What happens when you plug in 2? 2 squared is 4. 4 times 3 is 12. 12 minus 4 is 8. Could easily find it that way as well. Now, if I have that point at 2, 8, I would also, by symmetry, have -2, 8. Will I draw this with a solid line or a dotted line? Dotted. In reality, if I was doing this question, the answer would probably be I would draw a solid line and then realize I made a mistake and take out an eraser and erase it to make a dotted line. You will be amazed at how many times you do that. Oh, we got a solid line in pen. Strategic. And finally, we either have to use a test point or use the shortcut above or below. Okay? If I was using a test point in this situation, I really like 0, 0. If I was using the shortcut, am I going to shade above or below? Below. So I take any point on my graph and put an arrow below. That would be this section. I can go and shade. You guys should probably get crayons and bring them to class for your shading. So we're going to shade below. If I use the test point, I would plug in, my test point is 0, 0. I would plug in 0 for y. I would plug in 0 for x. And I would check the truth of the following statement. 0 is less than -4. That is false. So that section shouldn't be true, right? Okay. Is it possible to use a test point and make a mental math error? Yes. Okay. Sometimes people do is they do one test point, and then they try another test point in the same section to confirm. All right. Questions for practice on this one are, I'll give you some time to add some 4, 5, 6, 7, 10, and 11. Holy smokes.